Thank you, Nimi. And I'm very excited, very happy to welcome Mausam here. And then, in fact, um, you know, uh, if everything is went according to the plan, Mausam would have been organizing this event. But unfortunately, he's doing it now. He's giving a keynote from IIT Delhi. Uh, well, a dear friend and one of the brightest young stars, perhaps not as young as he is a few years ago. But then Mausam has been a really wonderful gift to Indian academic community. Currently, he is the head of School of AI at IIT Delhi and Jai Gupta Chair, Professor at the Department of Computer Science and Engineering at IIT Delhi. And then in addition to that, he's also affiliate faculty at Department of Computer Science and Engineering, University of Washington, where he has spent significant amount of time in, doing his research. So there are so many things to share about Mausam. And for example, he's been very well recognized, several awards, and and recognized by premier organizations and conferences like AAAI and so on. Most importantly, what I would like to emphasize is on how his work impacted NLP research across the world, connecting it more personally in IIIT Hyderabad, in LTRC, and in my lab, Information Retrieval and Extraction Lab. We've been continuously using Open AI, 5 and now it is 6. All of that has significant contributions from Mausam and his team. So not just that, there are several other research initiatives that he had taken, and worked on it for several years with same zeal, enthusiasm. His work is well known, especially inferencing over knowledge bases and working on the NLP for Twitter and other social media text. And of course, currently he is very interested in neurosymbolic AI and neural models for probabilistic planning and so on. But then I would like to share two other things the academic world may not be very familiar about Mausam. One is his other skills other than NLP, AI, and so on. He is fantastic in two things. One is classical music, other one is cooking. I was very fortunate to experience the first one, but still waiting for my turn to experience the second one. With that, Mausam, I welcome you to the KCS keynote talk. All yours.
Thank you very much, Vasu, for such a kind and loving introduction. I don't remember when was the last I cooked. I think my wife will disagree with you that I'm good at it. But I can. Your introduction kind of gives me the motivation to get at it again. So thank you very much for reminding me. It's an honor to be here at IIIT Hyderabad. IIIT Hyderabad, as we all know, is one of the most premier institutions which is doing excellently well in the field of AI. So I'm really happy to reach out to the IIIT Hyderabad colleagues and students through this talk. Before I start, I should also give a shout out to Rajiv. I unfortunately missed a lot of his talk early on, but towards the end, I saw the slide and the narrative that he was discussing, and some of the best practices that Rajiv mentioned on the slides, you will find mentions of them or hints of them throughout my talk. So actually, some of the points that he had raised were really, really valuable, and for a young student working in the field of AI, those were really valuable. For example, auxiliary laws or when to put human in the loop and things like that, build data in a cost-efficient manner. Those are like really important best practices, not just for industry, but also for academia. So, I really resonated with them. Today, I'm planning to talk about the next generation information systems as I see them. This is not just my vision, but definitely a lot of people in the community have been thinking about, how we are going to be interacting with information in the future. And we are all trying our best to, build it together. And I will share some of the works that have been happening in my group. Also, before I start, I should mention that, it is really not my work. I mean, I'm happy to represent it. But as we all know that, as Vasu also said, I am no longer young. So, a lot of the work really gets done by students. And I want to give a particular mention to some of the 4 graduating PhD students whose work I will be at least mentioning today. They are Danish Contractor, Prachi Jain, Keshav Kolluru, and Dinesh Raghu. Danish has just finished a few months back. Prachi is almost submitting, and Keshav and Dinesh would submit probably their theses in the next 3 months down the line. So that also means that suddenly my group, which had such amazing students that I could work with, is going to look a little bit empty. And so if you're interested in some of these ideas, some of the students here are interested in some of these ideas, you should feel free to reach out to me. I have had also the privilege of working with some amazing senior collaborators. In this case, I'll be talking about work that was done jointly with Professor Somen Chakrabarti at IIT Bombay, Dr. Sachindra Joshi at IBM India Research Lab, and Professor Parag Singla, who's at IIT Delhi, and lots of other undergraduate students and other students who have contributed to this work. So let me get started. At this point, I think I don't need to explain how much of an information overload we are dealing with on a regular basis. Now, I don't quite know if this quote is true. The quote says today a person is subjected to more new information in one day than a person in the Middle Ages in their entire life. Maybe that's a little bit of a stretch. Of course, we're talking about average person in the Middle Ages who will be, and the speed of progress of the whole mankind in terms of science and technology and everything else was slow, but more information, or more importantly, the information would not move very fast, and information would move really, really slowly in the world. But now we have all the access to the Googles of the world, all the news of the world, everything, and so we are really dealing with information overload. We have not been, we have not been trained to deal with so much information quickly, right? So, of course, there are mechanisms, there are devices, there are methods that are helping us sort it better, right? You be it Amazon, Alexa, or Google Home, or what have you, Microsoft Cortana and whatnot. But the point is that, what can they do today and what can they not do today, and what we can do to enable this in the future? Those are the kinds of questions that we are kind of discussing today. We really want to be in a place where we can get the information that we want at our fingertips, right? And Google 20, 25 years ago made a difference in our lives, where we would give a query and it will give us some, web pages. It will point us to the web pages where all this information really lies. Now think about it. If you think about it from the point of view of information food chain, basically there was World Wide Web, there is internet, and then Google is kind of ingesting all that information and kind of memorizing what information is present where. But now we are going to one next level of information food chain, where not only is it remembering what information is where, but it is actually ingesting the information at a level where it understands the information and can actually give us targeted responses. For example, if I ask the question, who won Big Brother OTT, Big Boss OTT in the context of Indian TV, then we really want the answer Divya Agrawal, and we don't really care where that particular information lies, right? Or if we say what sports teams are based in Arizona, we want a list of sports teams that are based in Arizona. We would not really want to go and read the web page where this information lies. Okay, but these are small things that even Google search engine has incorporated. You go and you try who won Big Boss OTT, you will get Divya Agrawal today. But when we can start asking more interesting questions, right? We can say, when did Asian Games occur? And here we are looking for, a list of answers, a list of years where Asian Games occur. But more importantly, we don't want to do it only in English. We may want to ask it in our mother tongue, like Asia Khel Kab Kab Hue, and we still want the same answer, even if there is no document in Hindi which kind of maintains this information, right? More interestingly, we can, because these are AI systems, we can start asking more predictive questions. When will they occur next? And now, if there is a sense that they happen kind of every 4 years, then somebody maybe the bot may be able to guess that they will most likely happen in 2022. Or moving forward, we can start asking more complex questions, right? Complex queries Like, I know Barack Obama, tell me all the various family members of Barack Obama, or some such query like that. And we might be interested in all these kinds of relationships that Barack has. Or, Rajiv was talking about reviews and, how we can deal with reviews, or making a shopkeeper kind of a bot. And one query that we might be interested in is, okay, how do you compare Roku with Amazon Fire Stick? And maybe an answer that we are looking for is some kind of a structured response where you know that both Roku and Fire can have support most apps, but they both have good UIs. But Roku really works perfectly out of the box, whereas the Fire sometimes blames router, may have problems in connecting, things like that, right? So the point being that maybe based on this we can get a very quick summary of what are the comparison points between Roku and Fire, which helps us make the best decision. Moving on, you can ask a more interesting question with respect to, let's say, restaurant recommendation, or a specific product recommendation, like suggest an Italian restaurant near Triple IT Hyderabad that serves excellent pizzas. Okay, and notice this is a hard question to answer, because to answer this question, a system has to first know where is Triple IT Hyderabad. It should have it should know what are the Italian restaurants. Oh, what is the address of Triple IT Hyderabad, right? Then based on that, there should be a Google Maps or some kind of a map system which can tell us what are the Italian restaurants nearby. But then we are interested in which of them serve excellent pizzas, and where would we get that kind of information? Maybe from customer reviews. And so you want a system which gives us all these answers that we are interested in tossing pizza, and I mean these are the good ones. And then we can have a chatbot on top of it. You can say, oh, can you make a booking for La Pizza tonight? And the system says, okay, for how many people? Right? So notice we are really talking about a vast variety of interactions between a human and a machine, asking simple questions which have one factual answer, asking more complicated questions which have lots of constraints, asking recommendation questions which have lots of constraints. Constraints could also be temporal. Where is it open now? Constraints could be spatial, near Triple IT Hyderabad. Constraints could be, more subjective. Does it serve excellent pizzas? It can also ask queries which are temporal in nature. When did Asian Games happen? In Hindi, when will they happen next? So we are talking about a really an information agent who we can really interact with, and ask a wide variety of questions, and it can give us those kinds of answers. And this is the kind of future we are trying to build together, right? So this whole idea of intelligent information systems kind of takes a standard data pipeline view where the data goes to information, which kind of goes to knowledge, which kind of goes to some kind of understanding. But in the context of information systems based on text, the data is the raw text that is available to us on the web. Important information from it gets extracted, and we call it information. Let's say these are factual triples or whatever. This information comes together from wide variety of sources and comes together and creates a large knowledge repository. And from there, we can anticipate that the specific user needs can be answered, right? So we can say text to facts to a knowledge base to some kind of an information system which is giving us targeted response. And so this is the kind of work I've been doing. So we have been working on the extraction side, which is the text to fact piece, which is also the part that Vasu referred to in his introduction for me, and which is also the place where I will be spending a fair amount of energy today. But we have also been working on other pieces of this problem. So one is knowledge-based completion and knowledge-based inference. Can we deduce more facts? Can we guess when Asian Games will happen tomorrow or next? How do we use these knowledge base in the context of applications, be it the human-facing, user-facing applications, or be it more NLP applications? Okay, so this also forms the kind of basis for my talk, sort of the outline of my talk. And before I start, I want to just make sure, I mean, today it's not an NLP. I don't know whether the audience has an in-depth understanding of the modern NLP or not. And it will not be possible for me to really go over, a lot of the developments in NLP, which is moving at a really, really fast pace. But let me give you a very quick primer. So before deep learning, we used to have features which were words or diagrams and things like that. But after deep learning, each word starts to have a continuous representation. Think of it like a vector of numbers. Okay. And the very first model that came out in this context was word2vec, where a word like king will go through a word2vec model to compute a vector representation for the word king. And the main idea was that it will you look at sentences where the word king appears, the other words in which context the word king appears, and there will be some analysis to figure out that, okay, words that appear together are similar, words that don't appear together are different, and let's create vector representations based on that. So this gave us one vector for one word, and you could ask interesting questions like, if I remove man from king and add woman, what do I get? So you can do operations like take the vector of king, subtract the vector of man, add the vector of woman, and see which word is closest to the resulting vector. And one found that the model had the ability to guess the word queen, or was the resulting vector was very close to the vector of the word queen. Later, many models came about, which I'm skipping, but one model that has sort of been is sort of unifying a lot of the modern NLP world is the transformer architecture, came out of Google. The main point was that one static vector per word is very limited because words have multiple meanings. If I look at the word bank, it could mean the financial institution or the river bank. If I look at the word spring, it could be spring the season, spring to jump, spring the spring we have in our pens, and so on and so forth. Right? So it said that based on the usage, can I generate an embedding or a vector for a word in context? And this is called contextual embedding. So, and transformer is one of the architectures which generates a context-based word embedding. So now, when I say I played on the bank today, the word bank may have a different vector from the sentence I withdrew money from the bank today, where the word bank may have a very different vector. Okay. Moving on, people use this idea and really trained large transformer architectures on humongous amounts of data. And one of the first famous models here is BERT, where it had some tasks. The tasks were again, predict middle word, predict, missing words, and so on and so forth. And so now, BERT, and these are called language models. And given this pre-trained model, so you will have a BERT architecture where you will again try to predict the missing word. This will pre-train the model. Now there is this large model that exists with us. We can use it. Now we have a new task like sentiment mining. We can give it some amount of training data for that particular task and just fine-tune BERT parameters. And after fine-tuning these BERT parameters, we will be saving on a lot of compute time. You can think of it as if BERT knows the language, the English language, and then you are just retraining it slightly for the specific task at hand. And even further ideas have been coming out, ideas of adapters and so on and so forth have been coming out, which I'm skipping for now. One last architecture that I would just like to mention, that a lot of the NLP tasks these days require generating text, like machine translation or summarization or even dialogue systems. Such architectures are called encoder-decoder architectures, where you can think about that the input is encoded by an encoder and the decoder generates the sequence. So for example, he is a good teacher, is English, and the appropriate Hindi would be ve achhe shikshak hain. So you can imagine that an encoder could be like a BERT or a transformer or some other architectures, and then a decoder could also be like a transformer or LSTM or some other architecture, right? So you can kind of create a sequence input to a sequence output, and this will become relevant in the very soon. Okay, so with this very high level primer, let us try to think about how we go from, for example, our first task, which is going from text to facts. Okay. Now, this is called the task of extraction, information extraction, and it has a very long history, almost, I would say, at least 30-year history, if not more. In the first iteration of this task, which I'm going to call closed information extraction, we were given a certain ontology, some kind of type signature of the relations of interest and things like that. And the goal was to give, for these relations of interest, can I go from the sentence to an extraction? For example, if I have a sentence, Apple's founder Steve Jobs died of cancer following a long battle, And if in my ontology, there is a relation called founder of, which is between the company and the person, a closed eye system will say, I see an instance of the founder of relationship mentioned in this sentence, and I will extract the triple founder of Apple, Steve Jobs. So if in my ontology I had 50 such relations, then I would train my closed eye system to output instances of those 50 relations. And for each relation, I will usually need some training data. Okay. So I may have a list of founders extracted from text. I may also have a list of acquisitions extracted from text, but I may not be able to extract a random relation which I have not trained the model for. In contrast to that, an open information extraction paradigm was developed. It happened at University of Washington while I was there, and later it became one of the agendas that I was running with. So the goal was to extract all kinds of information of all relations in all domains in just one or two passes. Basically, we didn't want to start and be bound by a vocabulary like an ontology. We really wanted to extract everything. And what does that even mean? So in the context of OpenAI, it means that the relation itself will also be a phrase, a textual phrase. For example, for the same sentence, Apple's founder Steve Jobs died of cancer following a long battle. An OpenAI system will say, this sentence mentions a relationship between Steve Jobs and Apple. And the relationship probably is something like, is the founder of. Notice the word is the of are not in the sentence, but the word founder is in the sentence. So mostly these are words that are extracted from the sentence, although some kind of closed class words are added. Similarly, an OpenAI system will also say that I also see a relationship between Steve Jobs and cancer, which is mentioned in this sentence. And what is that relationship? Died of. And so an OpenAI system will also extract Steve Jobs died of cancer. So notice that you don't need to give it a relationship is the founder of or died of ahead of time. It just understands properties of language and deduces that these are the relationships that are being mentioned in the sentence. So now, not only can I get Google acquired DeepMind, but I can also get oranges contain vitamin C. Edison invented the phonograph. Steve Jobs is the founder of Apple. And then I can ask questions like what kills bacteria, and my system will be able to give us a bunch of answers. So let me share with you, let me show you a quick demo, just so that we are all in the same page. And I know that you are not able to see my screen, so let me share my screen again. So I hope you can see the demo, and you guys can play with it. This is online. So let's say I ask the question, what kills bacteria? So what does that mean? It basically means I'm looking for relation kills with the argument to bacteria. And when I search, it gives me a bunch of answers. So it tells me antibiotics kill bacteria. And you can look at which sentences it was extracted from. Antibiotics kill beneficial bacteria, the antibiotics kill off all the bacteria, etc. Antibiotics are used to kill bacteria, and so on and so forth. Or you can see vinegar, right? So the vinegar kills bacteria. Look at this sentence. Vinegar absorbs the excess oil secretion and kills bacteria as well. And this is a little bit of a long range dependency, but the model was able to extract that vinegar kills bacteria. Of course, it is not perfect. And so it also feels that water kills bacteria, which is, where is water? Yeah, water kills bacteria, which is not quite right. Because usually the thing is it can be used to boil water, which kills bacteria. So boiling water kills the bacteria, not water itself. So there was some entity normalization mistake. There are some co-reference things that it has not done. For example, it says this process kills bacteria. So it has now figured out that, okay, this process can kill bacteria. Of course, that's not enough because you need to know what was being mentioned in the previous sentence to figure out which process kills bacteria. So the good news about this model is that you can come up with new questions that you may not have thought of before and ask those. For example, what is the symbol of a country? Symbols of countries. So we are looking for a relation symbol of, argument is to be identified, argument 2 should be some of the type country. Okay, so when we ask such a question, it gives us maple leaf is a symbol of Canada, kiwi is a symbol of New Zealand, and it tells us that it's a national symbol of New Zealand, etc. Tiger is a symbol of India, and so on and so forth. So you can think about new questions that you are interested in and see whether you have, we can answer these questions. So I have not done this. I am taking a chance. I am just asking if it knows what, let's say, let me see if it knows anything about Triple IT Hyderabad with respect to its relationships with person. Maybe the answer is none. Okay, it doesn't know about Triple IT Hyderabad. Maybe it knows something about just Triple IT. It kind of does it. Okay, so never mind. It doesn't always know things, but the point is that we can try to ask such questions and figure out what it knows, and that gives us the first version of getting to the targeted kind of setting. Okay? Now, let me go back to my presentation. Okay. So, so now this OpenIE model, which Vasu also mentioned briefly, we have been doing this for a fair amount of time now. So it has almost 13, 14-year history now. And I joined hands on this problem since 2010. So starting OpenIE 2. And the last OpenIE, the latest OpenIE is OpenIE 6, which we have released about a year and a half back. And there is a long history, which I am not going to get into, how we increase precision, recall, expressiveness, and so on and so forth. But let's just start thinking about what's the latest on it and what are the neural models that are being used for OpenAI. Okay, so there for the next 15 minutes, I will try to get into a few models just to have our some kind of deep learning exposure for the students who have deep learning experience. And then towards the later part, I will just talk about the other problems that we have been working on and not really get into the solutions. Okay, so this is our goal. We want to go from a sentence to a set of extractions. So in other words, we want to create an OpenAI system where the input is a sentence and output is a set of extractions. Now you can think about it. You can think of an encoder-decoder architecture. The input will be going to the encoder and the decoder will spit out these extractions. But there's a problem. What's the problem? The input is sentence. That's all right, not very hard. But the output is a set of extractions. Now, up until then, there wasn't that much thought about how do we output sets. So what exactly is a set of extractions? It's a set of sequence of tokens, right? So extraction is a sequence of tokens and set of extractions is a set of sequence of tokens. Right? So now the first question is, how do we output a set? Because set is kind of order invariant. Right? But then when we thought about it a little bit more, if I ask a human, give me a set of all colors, and it starts to say red, green, blue, white, brown, it will still give that set to me in some order. So when we actually communicate with each other, a set is always serialized. A set always becomes a sequence. So we took the same view and we said, okay, let's just output the set one at a time, just like a sequence. So we went from outputting a set of sequence of tokens to outputting a sequence of tokens. The second problem is, because we are outputting a sequence of tokens, it's a long sequence that we have to generate. Are the neural models good at generating large output sequences? And we found that they are not very good. So we decided that we will output only one extraction at a time. We will not output this whole thing into one long generation. That was the second change we made. The third question was, how do we even ensure if we are generating one extraction at a time, how do we ensure that the model does not keep repeating the same tuple again and again and again and again? This actually happened in dialogue systems. The model will just stutter. It will keep saying the same word again and again and again, or the same, in this case, an extraction. And so we said, okay, it needs to remember what has been generated so far, what has been extracted so far. So we will need to give all the previous extractions as input so that it knows where it is in the generation process. These three design decisions led us to the model which we call emoji, iterative memory-based joint OpenIE. The main idea is the encoder is the standard BERT encoder. The output is the decoder is a standard LSTM encoder. The details of the copy and the attention I am actually skipping right now, because for that you will have to take a deep learning NLP course to get a sense of, but these are not very complicated ideas. The copy model just says copy words from input to the output, and attention model kind of says which part of the input should I be focusing on at the time I'm generating the next word. But the main thing is what goes into the input. And what goes into the input is the full sentence and also the previous extractions that have been generated so far. So you can see this original sentence followed by the first extraction, second extraction, I minus 1th extraction, and then I am generating the ith extraction one word at a time. So just take an example. This is my input. Apple's founder Steve Jobs died of cancer. The CLS token is something within BERT. We'll skip it. Separator basically means this is the end of sentence and maybe some more input is coming. And based on that, I create contextualized word embeddings. We have talked about them. And using those contextualized word embeddings and the copy and the attention module, I generate the word. I say, okay, generate argv1, it generates Steve. I say generate, now I have generated Steve, generate the next word, it says jobs. I say, okay, I've generated jobs, generate the next word, it says rel. That basically means argv1 is done. Now it is generating the relation. Then I keep doing this, then it generates is, the founder of, then it says arg2, then it says Apple, and that's how the extraction is generated. And at the end, it says end of sequence, basically means I have generated one extraction. And now the next extraction that I'm generating, I will give all this as input to BERT again, and then it will again create contextualized word embeddings. So by doing this, it reduces redundancy of extractions because the extractions are now in the input, and there are only small generation sequences per decoder, so it's actually able to do a good job. Okay, so this is the emoji architecture. The main problem is it is slow. Why is it slow? Because to generate every extraction, I have to give all the other extractions as input, and so I have to run BERT again every time. So the encoder gets run every time I have to generate the next extraction, and that makes it slow. Okay, so at a high level, I'm skipping on the very specific details of the evaluation, but think of CARG as one of the data sets to evaluate OpenIE, and the F1 and area under the precision recall curve are the standard metrics. And I also show you the speed. Okay, and we compare against OpenIE 4, which was the previous generation system, non-neural system. RNN-OI was the next neural system, and emoji is our system. So you can see that it is doing much better than the non-neural and the neural systems, but we also can see that its speed is really slow. It is only processing 2.6 sentences per second. So we are not very happy with it. You can also see that there is some trade-off between speed and accuracy because of these systems. Emoji is 4.5 F1 better than RNN-OI, but it is 60 times slower than RNN-OI. We don't like this. Just saying that this code has been available and it has been downloaded 3,500 plus times. We don't know who have downloaded it, but sounds like Vasu's team is one such group which has downloaded it. So thank you, Vasu. Now we said, look, we want to do better. Why? Because we want to improve the speed, but not without compromise. I mean, we don't want to compromise quality. So the next idea was that generation is becoming too slow. Let us do sequence labeling. Okay, what is sequence labeling? In sequence labeling, every word gets a label. So Apple will get a label, apostrophe S will get a label because it's called independent punctuation. And we can add some close class words like is, of, from, etc. also as labels. And Keshav realized that, look, every extraction can be thought of as a labeling. So if you look at this first line here, arg2, none, rel, arg1, arg1. Let us look at the arg1s. What is the arg1? Steve Jobs. What is the arg2? Apple. And what are the relation words? Founder is of. And then you need some reconstruction to say, okay, we are maybe talking about is founder of. So second extraction is Steve Jobs died of cancer. And again, you can say arg1, arg1 for Steve Jobs, rel for died of, and arg2 for cancer. So basically, every extraction can be thought of as one labeling of the sentence. And if we have multiple labelings of the sentence, we can create multiple extractions. So he took this view and he called it grid labeling. Okay, we are talking about the work of my PhD student Keshav Kolludu. So this is his work. Keshav is the student. So Keshav realized that we can possibly do iterative grid labeling. So the idea is that I want to label a grid iteratively. So basically, I give the sentence as input, run BERT on top of it, then do some decoding to create some labels, right? Like the first labeling here, the first row of labels. Then these row of labels get some embedding also and get added onto the output of the transformer to create a new input for the next two-layer transformer, which generates the next extraction, okay? So every label classifier gives me one extraction, but the output of that goes as input to the next label classifier, and so it's kind of remembers what has been generated before. So we are avoiding the re-encoding time through BERT. That saves us time. And this is how the iterative grid labeling works. So the first transformer will generate the first row E1, then the second will generate next row E2. At some point, it will say, I am done. So it will just generate a bunch of nuns. And so then we will stop. And when we did this, we were able to find a much faster speed. So 142. So look at IGL OIE and compare it with emoji. Emoji was 2.6 sentences a second. IGL OIE is 142 sentences a second. So we are pretty much as good as RL and OIE. But we were, about a point F1 lower than emoji. So we have solved the speed problem, but we have lost a little bit on the quality. And this is a known trade-off sometimes, right? Full generation is more powerful than labeling. Full generation is also much slower than labeling. Can we take the sequence labeling approach but make it faster? That was the next question that Keshav asked. Around that time, one of my other students, Yatin Dandwani, had been thinking about adding auxiliary constraints in the context of neural models. And he had written a very nice NeurIPS paper a couple of years ago about, how do I add constraints and train a fast enough deep learning model so that these constraints don't act as, they don't take time when you are doing inference. They are helping us at doing better learning. Okay? And so Keshav got some interesting combination of this constraint idea in the context of OpenAI. So he looked at what makes a good set of extractions. Like if I have the sentence, Obama gained popularity after Oprah endorsed him for the presidency, if my system only extracts Obama gained popularity, we will say this is not a very good system. If it also extracts Oprah endorsed him, it starts to get a better system. But if it says Oprah endorsed him for the presidency, we will say it is even a better system. Why? Because it is capturing more of the information that the sentence has. So basically, he realized, Keshav, that more important words like the nouns, the verbs, maybe the adjectives, they should be in some extraction because they generally convey information. How do I improve these? Well, I can add constraints that say that words which have these part of speech tags should be part of at least one extraction. You can impose it as a hard constraint, or you can even impose it as a soft constraint. And in NLP, generally soft constraints will turn out to be better because, word doesn't really work in that cutthroat, hard, soft manner, right? So generally the soft constraints are better. So he used Yatin's ideas, I'm skipping the details, and created CIGL, which is constrained iterative grid labeling architecture, where it did not change the speed of inference because the constraints were only used at training time. It may have made some, training slower, but that it's okay. And it even got better results than emoji while at much faster speed. And this is what we have packaged in the code that we call OpenAI 6. And this has also been downloaded almost 1,800 times now. And that was the main contribution, that we can now have fast architecture, which is also equally high quality. Keshav has since moved on to multilingual versions of OpenAI. And there again, what Rajiv said resonates with me, that look, you can create English OpenAI because we could think about English specific training data. We can also create Hindi OpenAI. What's the big deal if we can put together Hindi specific training data? And I would say that folks at IIIT Hyderabad are the people I always look up to when I look at Hindi training data or training data in specific Indian languages. But it's very slow process. Creating training data for each language is a lot of effort. So the question that Keshav asked is, can we automatically curate training data for a different language by translating English data? If we do this, then we will be able to solve the training problem to some extent. This is an English, maybe Portuguese example here. So he said that, okay, let's take an English sentence. The shield of Athena Parthenos depicts a fallen Amazon, right? And then you have an associated English extraction that the shield of Athena Parthenos depicts a fallen Amazon. This is a training data tuple that I have, sentence extraction pair in English. Now, I want to create an equivalent tuple, training tuple in Spanish, let's say, or Portuguese. What will I do? I will do machine translation. So I will convert English sentence into Portuguese extraction sentence, And for the English extraction, maybe I can make it into English, small English sentence. I can again do machine translation and create a Portuguese extraction, or actually Portuguese sentence, small sentence. And then I can do some kind of an alignment to figure out, okay, which words in argument one, like the shield of Athena Parthenos, relate to which words in the translated sentence, like in this case, El escudo de Athena Parthenos. And then I can create this as my training data. Okay, so this would be what we will call the vanilla pipeline. Now, what was the challenge? The challenge that we observed is that notice the word fallen in the original sentence. It has many Portuguese equivalents. When it translated the English sentence, it used the word falecido. When it translated the small English sentence from the extraction, it translated into the Amazonas chaido. And now both of them are correct, but this is not a good training tuple, because I'm training the model that when you see the word falecido in Portuguese, you convert it into the word caido in extraction time. This will confuse the model. So obviously we don't want this. So Keshav created what is called the alignment augmented consistent translation, where for each word, he also created an alignment and then asked the model to use constrained empty so that it uses the word falecido rather than caido. And when we do this, we create better training data. And this leads us to creating OpenAI extractions in many languages at once. And he experimented with Spanish, Portuguese, Chinese, Hindi, and Telugu. And because we are in India, we really want to add some training data sets and test data sets for our languages also. And Keshav speaks Telugu, so that was easy for us to do. And we found that we can even get 20-point F1 improvement and 10-point AUC improvement over prior models using this architecture. By the way, multilingual is becoming an important part of my research trajectory right now. And so we have also been looking at multilingual closed IE, and we have a couple of papers where we have proposed a data set for multilingual closed IE and also a new baseline for taking this work forward. Now, after doing all these extractions, so by the way, this is where I was going to focus a little bit on the techniques also, but now I'm going to just give you a flavor of the other works that we have done and how we have used these extractions and things like that. So the next question we asked is, if I have all these extractions, what am I going to do with it? So the good news is that the extractions are human interpretable, so human can easily look at them, and they become a great way to summarize. For example, this is some work I did for IARPA, one of the defense agencies in the US at the time, where they were obviously looking at terrorist organizations at the time, and they were interested in if my intelligence analyst can quickly understand a terrorist based on OpenAI extraction. So suppose I give an input to this system for this Mr. X, my system would be able to use the existing OpenAI knowledge base to create a small summary for Mr. X. Like Mr. X is operative of Al-Qaeda, is the military chief of Al-Qaeda, is a strategic planner of Al-Qaeda, he has married somebody's eldest daughter, he was in Iran, he was in Pakistan, he's in the list of FBI's most wanted terrorists, he was a mastermind of some attack, he coordinated the operations, etc. So in 2 minutes, you quickly know who is Mr. X, what is his, kind of dossier, and without really reading a lot of the documents. So this is a great way to summarize and reduces the information overload for humans. I was not the only group thinking about this. So a lot of people have been looking at scientific literature, sometimes in the context of healthcare. And this is some paper that I found where they have used the OpenAI extractions to try to figure out how does Alzheimer's disease on the left connect with another disease, let's say Huntington disease on the right. Okay, and so they were able to create these two-step paths using OpenAI, where Alzheimer's disease is the most common cause of cognitive impairment, and cognitive impairment is also an early symptom of Huntington's disease. Okay, similarly, both may have vascular dysfunction, but Alzheimer's disease is correlated with an APOE genotype, but it does not correlate with Huntington's disease. So very quickly, we understand how they are similar and how they are different, right? We ourselves looked at this in another context. We looked at entity comparisons. And this is work by Danish Contractor. He was very interested in traveling. And so he loved to see, how do I compare entities, maybe for cities for traveling. So of course, comparisons can happen for presidential candidates or for, products or for humans, not humans, superhumans per se. But he was interested in where should I travel next, right? So this is an output of a system where he was able to use extractions to compare Granada, Spain with New York City, US, for example. And these cluster labels were automatically generated. The actual extraction things were automatic. And very quickly, in 2 minutes, you will be able to see that um, Granada has palaces, New York City does not. B, both have art, but New York probably has a little bit more contemporary art, whereas Granada has a little bit more religious and fine art. And both have gardens and parks, right? So very quickly we get a sense of, how do these two cities compare from the context of travel? And later you can read more carefully one or two shortlisted cities if you're interested in travel. This could also be extended. He extended this to movies, and this could also be extended to, Roku versus Fire example that I started with. How am I doing on time? So how much more time do I have? So that will dictate how much I sort of cover some of the other topics.
Maybe, Vasu?
Right, another, I think 15 minutes for sure.
Yeah.
Fantastic. So let me give you a little bit of a flavor of what we have been doing on the inference side. The question here is, so first of all, we extract all this information. This goes into knowledge bases, closed knowledge base or open knowledge base. I already showed you the example of OpenAI knowledge base here, but there are many other knowledge bases that people have put together. Freebase is one, Google Knowledge Graph, Yago, so on and so forth. Now, it is not our work, but people sort of generally recognize that knowledge bases are useful, but generally incomplete. For example, if I'm interested in, if I look at Freebase and ask for people's parents, I will get 98% of the time, I will not be able to get an answer. If I'm interested in the educational profile, 79% of the time, I will not be able to get an answer. So basically, you can't cover all of human knowledge, you can't stay current, and existing knowledge bases are highly incomplete. So can we detect, can we guess new facts? For example, if I give you this knowledge base, or we often take the knowledge graph view where the entities are nodes and the relations are edges. From this knowledge base, we can predict that Barack Obama has nationality USA, even though it is not explicitly mentioned. Why? Because he was born in Honolulu, which is a city in USA, and he, for now, that is the only guessing point. His spouse is Michelle, who is also a US citizen, but that may not be a strong indicator, right? But later, if you knew that Barack Obama is also the president of USA, that's an even stronger indicator that he's a citizen of USA or he's a nationality USA. Can we predict such facts? Now, there's a lot of work going on knowledge-based completion, and we have done a couple of papers also. This is, by the way, that those papers are work of Prachi Jain, my PhD student, who's just finishing up. But we were asking some other questions, so slightly different questions. So one of the questions that I asked was, can we ask interesting queries, right, to the knowledge base? And can we use knowledge base completion to answer those interesting queries? So they're simple queries like who founded Microsoft? You can think of it as Microsoft founder question mark, and I want to find the question mark. This is an easy query that generally people in knowledge base completion world study. Then Percy Liang introduced this idea of multi-hop queries, like where do founders of Apple live? So here I'm saying Apple founder lives in question mark, right? So whoever is the founder of Apple, where does he or she live or where do they live, right? So there can be multiple answers here because there can be multiple founders or multiple lived in cities. And when we did some analysis of a user query Wikidata log, we found that single hop queries are obviously 87% of the queries that people ask, but multi-hop queries is only about 1%. And often people ask more interesting queries like regular expression queries. Like, for example, list all the family members of Obama, which is essentially Obama, tell me the son, the daughter, the spouse, the parent, this uncle, aunt, whatever. Or find all the colleagues and their colleagues and their colleagues and the clean closure of somebody, right? And things like that. You can actually even compose them together, like Obama's son, daughter, spouse, and their clean closure. So the son's sons or son's parents or daughter's husband and things like that. So you can start doing a really large family tree if you build these regular expression queries. Now, of course, how do I answer these regular expression queries over incomplete knowledge bases became a challenge, because now I have to first make my model compositional, because I can put together these in many different ways, like friend, all peers, clean closure, or clean closure, or clean closure of something else, things like that. And also we have too many entities as answers. And when we have too many entities as answers, many of these knowledge-based completion queries don't do very well. So essentially, we had to come up with operator models, which we can put together in any kind of a graph, and also think about box embeddings. And I will not get into box embeddings, but box embeddings is a good answer for when your queries have many entity answers. So we created a model called rotatory box. This is a work of one of my staff members, Vaibhav Adlakha, who's doing his MS at Mila now. And we found that it does much better from existing approaches. And we also created a new task and a new data set, or two data sets associated with it. Then Prachi continued her work on knowledge graph completion with temporal knowledge graph, where with each fact we have mention of the time, right? For example, and we can ask very interesting questions. One question we can ask is, when would something occur next? Like, for example, I know that Super Bowl in 17 happened on February 5. Independence Bowl happened on December 16, 2015, December 29, 2013. LA Marathon happened on these dates. Now, when would Independence Bowl happen next? And when you look at it, you can kind of figure out that it happens on last week of December. So you can guess that, okay, most likely it will happen on the last week of December, one of those dates, maybe Wednesday or Thursday or something like that. Similarly, Super Bowl generally happens on the first Sunday of February. So Dinesh Raghu, this is actually work by Dinesh Raghu, he recognized that there is a schedule implicit in the data that I am given, and that schedule can be used to predict future instances. Prachi did more temporal knowledge-based completion, and she said, okay, up until now I have been doing link prediction, where find me the missing argument and so on and so forth, but I can also do missing time prediction. For example, when was George W. Bush the president of USA? And tell me what is the starting time and the ending time. And she created a model called TimePlex, which takes away extends knowledge-based completion models. And here's a very interesting query that it is able to answer. So let's look at this query. So there's this person, Shin Era, in the training knowledge base, and we know that he is married to somebody, and he married to this person in 1995. Now the question we ask is, when was Shin Era born in South Korea? We know that he is born in South Korea. The question is, when was he born? Okay. And now you and I can very easily figure out that, okay, he got married in 1995. First of all, he was born before 1995. Most likely he was not born in 1994 or 1993. South Korea did not have, Bal Vivaha. So basically, most likely he was born a little bit around the, 60s or the 70s or something like that. And this is what kind of our model predicts also, the orange model, the orange line. It predicts somewhere around, the gold is 1969, and the model kind of predicts something like 65 or 67 or something like that, right? But the baseline model that existed for this task, the blue line, is the TNT complex model, and it basically had a flat line, and it did not have this common sense. So our model was able to deduce all this common sense completely automatically from data, and kind of guess that what are the typical ages. Actually can guess that typically the difference between married and born in is approximately this much amount of years. And again, all the with every work that we do, all the code is available, whether I have this on the slide or not. So, okay, so this is how we kind of improve the overall coverage of the knowledge bases. So now the last question is, what are these knowledge bases really useful for an NLP minded person? So they're useful for humans in information summarization, but can they be used for downstream NLP tasks? And again, believe it or not, we have also used them for word vector training and so on. But recently I have been working on two tasks. One is the complex question answering task. Again, from the travel domain, this is work by Danish Contractor. This is the kind of question that he wanted to answer. Basically, you go to this website, his website, if he will create this, this is a really, startup idea, and he will be able to give you recommendation. Excuse me. So what's the question? I'm taking 15 scouts to New Zealand over Christmas and New Year. We are spending New Year's Eve in Auckland, and we are looking for suggestions for restaurants maybe buffet style, which will be suitable for the large group. Ideally close to somewhere we can watch the fireworks from. Any ideas will be welcome. Now look at how complicated this question is. It will take you 30 seconds just to understand what the user is trying to ask. And expecting that a machine can answer these questions is a really hard challenge. This is the summary. User plans to take 15 children on New Year's Eve to Auckland. Restaurants that can accommodate large groups. He wants to watch fireworks. So something is attribute about the user, which may not be very interesting for us, but this is temporal information. This is the location of the answer. These are attributes about the answers, right? And so what first he did was he converted this question into kind of a more complicated SQL query. Select X, where X subtype is restaurant, location is Auckland, and then X has some attributes. What are the attributes? Buffet style, suitable for large groups, etc., etc. Notice that some of these things are more sort of categorical, like restaurants in Auckland, but some of these things are more textual, like buffet style and suitable for large groups. That was the first thing he did to answer these questions. He converted this and did some needed explicit annotation to go from question to this SQL query. Then he said, I don't want this additional annotation. I want to work in an end-to-end training regime. So there were lots of challenges. How do I get the data? How do I handle large number of reviews per answer in a neural model? How do I handle large answer space? There were lots of these challenges, which I'm kind of skipping. And he was able to create one neural architecture with tricks and heuristics and insights, which kind of did this completely automatically. So you give it a question, the neural model will have an encoder to encode the question, then do attention on top of exemplars over each candidate answer to predict whether this candidate answer is appropriate or not, and it will give us some good answers. Later, he also looked at queries like, close to IIIT Hyderabad or something here, where this person says, I am staying at Hotel Florida. I'm interested in a good restaurant nearby so that I don't have to walk too far. And this is what he called, Danish called spatio-textual question answering. So we have a textual constraints and we have spatial constraints. And again, he has an end-to-end neural architecture to do this. And he showed that his end-to-end neural architecture did a much better job on spatial reasoning than his previous architecture. We have also looked at these kinds of recommendation tasks in the context of dialogue systems. So here is a dialogue engine problem where the user says, suggest an expensive restaurant that's in south section of the city. The agent asks, do you have a cuisine preference? The user says, no, I don't care, but I don't want to spend a lot of money. Agent says, okay, how about Peking restaurant? Okay. And at the back end, what agent does is it says, okay, the user is looking for the location to be south and price to be moderate. Cuisine can be anything. Goes to the knowledge base, gets the results, uses these results to make predictions. Okay. So it can ask about attributes. It can create a knowledge base query. It can use the results of the query to make predictions. Now, what was the problem? The problem was that, the previous systems that we started with would make a random prediction. Like if I ask what is an Italian restaurant, they may say, Sarvana Bhavan, right? Or in this case, we know that the model has, the knowledge base has suggested restaurants like Rezo, Taj Tandoori, and Peking restaurant, but the model says Olive Garden. Now, why does the model say Olive Garden? Because the model has memorized from training data that Olive Garden is a good answer to these kinds of queries, even if the particular knowledge base does not have them in the context of this particular user query. So the challenge is that when you train the neural model with language, model doesn't know what part of it is language and what part of it is knowledge. So model starts to memorize knowledge as if it is language. And so when the new problem comes, it just says Savana Bhavan because it has seen that at training time, whether Savana Bhavan is in the city or not. So we had to come up with some architecture to disentangle language and knowledge. And I'm going to skip the ideas, but we had to put together a new loss function, auxiliary loss function, and a new dropout function to get this to train right. And we showed that even if I have at 100% level, no entities in the answer set seen at training time, our model, the blue line, is robust to that, and other architectures either are terrible performance or not robust to the disentangling between language and knowledge. And recently, one of my students, Dinesh Raghu, and another master student, has improved on the Boston architecture, and they have now, I would say, nearly state of the art now numbers on these tasks: Camrest, SMD, and WAS 2.1 data sets. The architecture is called CDNet, which I'm kind of skipping. So I have been really taking you through a whirlwind tour of a lot of activities happening in my group, giving a little bit more focus on extraction, but talking about many interesting problems in this space. Notice that these problems, there's just a huge number of problems in this space. I mean, the sky is the limit, as we say. I mean, you can think about even just simply combining one PhD student's work with another PhD student's work is more interesting, because notice that the complex question answering work and the dialogue system work is still separate, because in dialogue system we don't ask very complex questions, etc. Right? So just bringing them together, doing some prediction on top of it. So I have one student looking at knowledge-based completion in the context of dialogue systems. There's just a lot of research that needs to be done here to make a system that really can solve all the challenges that I enumerated in the beginning. I would also try to tease apart some best practices, although I think Rajiv did this much better than I did. The question is, can general end-to-end machine learning figure out all this just by the data? And Vasu mentioned about neurosymbolic AI that I'm thinking about. My answer is no. My answer is that, look, for every problem you will have to do something specific, be it a problem specific construct, a model component to capture those, which we had to do for emoji because we had to answer output set of sequences, or timeplex, where we had to somehow incorporate the temporal relationships between the relations, or spatio-textual QA, where the neural architecture had to do spatial reasoning and it was very different. We had to use features or constraints when they made sense, like in OpenAI 6, I showed you that adding constraints improved the quality. We added auxiliary loss when it was appropriate. For example, in BOSNet, we had an auxiliary loss to disentangle language and knowledge. Sometimes intermediate representations benefited us, like when we had the schedule for the next prediction of the occurrence of an event or a question parse. And sometimes we have to just generate training data automatically because training data itself is not easily available, which we did in the context of multilingual OpenAI. So I don't have one size fits all, one overarching principle for you, but I think for a given problem, there are lots of these, I would say, tricks, tools, ideas that you should have in the arsenal. Create new data, create intermediate representation, create losses, just change the architecture completely, add constraints, put human in the loop, whatever it is. And once you start doing it, then you will be able to solve this problem and will be able to take the next step forward. Okay. Thank you very much for patiently listening to a very long talk. I will just stop with two quick shameless plugs. One plug is my NPTEL AI course. So over time, my AI course became a little bit very fine-tuned and refined, that I have put it on NPTEL, and every year, this is the third year running, and almost 40,000 students sign up for the AI course. And I encourage you to have a look at it. You will enjoy it most likely. The other plug I want to give is about School of AI, of which I am the head. And School of AI was started only 1.5 years ago in IIT Delhi, but we have already started a PhD program, and the PhD students are working at the intersection of AI and some other technologies, like applying AI for computer vision, machine learning for computer vision, or applying AI for material science discovery, or cement manufacturing optimization, or things like that. So basically, can we take the ideas of AI and really take it to realistic applications? That is kind of the idea of School of AI, and we are also innovating on core ML contexts. The other thing is that an MTech program is starting in School of AI this July, and the admissions are open right now. I really encourage you to apply for them. For the MTech program, it's a very, very interesting program that we have put together, and you will have a great experience on that. So I will stop by thanking all the people, all the various sponsors who have funded my research, and I'm happy to take any questions. Thank you very much.
All right. Thank you so much, Mausam. It's again, like always, it's been, you take us through a fantastic ride with so many, like a vista points, several vista points, and then great experience. Thank you. maybe I'll start with one question. As all of us know, any open IE endeavors will result in lots of noise because you're dealing with the wild text. So what are some of the things, or tricks or techniques that you would recommend or you used in order to deal with the noise in the extraction?
Right. I think that's a great question. And there is a lot that can be done in the context of noise, some of which we had done in the past, and some of which other people have also investigated. So first of all, one has to do co-reference resolution on top of OpenAI, because we want to resolve the he, she, it, the school kind of references, the process kind of references, so that the information is more meaningful. The second thing that people do generally is that they do a little bit of entity linking. So when you start doing some entity linking, like you look at the entity vocabulary or the entity repository that you have and try to connect words with the aliases, then you start to find more meaningful extractions there. And that helps us in sort of focusing our energies on the extractions that are relevant to for the task at hand. I will actually show you the particular demo which I showed you in the, not the demo, but the slide. And here is one thing that I would like you to notice that there is a little bit of a sequencing that we have done on the extraction. So not every extraction is useful. For example, Mr. X would be a major coup is actually a nonsensical extraction. Or Mr. X illustrates his interests is kind of a boring extraction. But notice that they come a little bit lower down the order. Why? Because, we noticed that, this has a noun phrase or an entity at the other side. So it is important. This was extracted many times, so it is important. It was extracted from a noun phrase, and so the noun phrase based extractions are generally more important, etc., etc. So those kinds of ideas allowed us to remove some of the noise. Then the next thing we can do is that if you have a specific domain, then you do a little bit of annotation to figure out which extractions are more important to you, which are not, and train a downstream classifier to say whether this is an important extraction or unimportant extraction. That allows you to do a better job on the ranking also. Often I have seen that for specific domains, there are some rules that you can write. And these rules allow you to get more information or sometimes improve the quality of information. Like, for example, Triple IT Hyderabad, parentheses, Indian Institute or International Institute of Information Technology, parentheses, end. And the sentence continues. Now, from this, OpenAI will not extract something, but here, if you remember that, there is an acronym followed by a parenthesis, followed by, something which matches the acronym at a high level, then you can start to understand that Triple IT Hyderabad is same as, International or Indian Institute of Information Technology, things like that. The point is that, we have done all these kinds of activities for specific domains. These kinds of added patterns really help.
Great. Thank you. That's very insightful. I have one question that coming from one of my students here. So we are, in our lab, we are working on a problem that is exactly the reverse of what you described in the context of open information extraction. That is mostly, it's basically taking from the text, you are extracting facts and pieces of knowledge and then storing it in a knowledge base and then improving those facts and so on. How about the reverse problem where you are actually looking at the knowledge base or fact or a knowledge graph and then generating text out of it? So for example, we have a great number of applications like creating encyclopedic knowledge like Wikipedia pages on certain topics. For example, in Indian languages, many of these topics are missing. Now, can we enrich Indian language Wikipedias in Indian languages using some of these techniques and so on? So we are using certainly, some of the knowledge bases that you mentioned, but of course, there are a multitude of these knowledge sources, especially the knowledge graphs, starting from Wikidata to many other things that you have mentioned. Now, any suggestions, any like pointers in kind of achieving this reverse act in an efficient way?
Interesting. So here is one thing I would say, which, by the way, if you are looking at these kinds of problems that you will be really interested in, think about quick info. All the cricket news that comes in, live that it comes, one ball at a time. We had a course project that unfortunately did not see the light of the day, but they made an amazing demo where you just give it the link of the match, cricket match, and the model will create a summary completely automatically using just the ball-wise report, because it will identify which balls are more important because salient events happen. It will generalize, aggregate. It was very, very, very interesting. And this is again one of those places where small bits of information need to be put together to create a longer document. Now, to answer your question, though, there's a field called fact linking. So first of all, you may want to look out fact linking. So the idea there is that you have a knowledge base fact and you want to link it to existing sentences in the corpus where that fact may be mentioned. This is different from generating sentences. But fact linking might be able to give you training data for training a model which generates sentences. The other thing that I would say is that generally there are a few number of relations in every um, um, knowledge base. For example, as far as I know, Freebase has about 2,000 relations. Yago also does not have too many relations, and so on and so forth. When your number of relations are small, you can easily serialize those relations in small templates, which will allow you to go from a fact to a simple sentence. Once you go from a fact to a simple sentence, then you can look at sentence fusion kind of methods to take multiple sentences about the same entity and fuse them into a single one sentence. And actually, again, people have done it on both sides, sentence fusion side as well as sentence simplification side. So people who do summarization do both. They sometimes do sentence fusion, take two sentences and write a small summary sentence, and they also go from take a long sentence and remove parts of it to simplify the sentence for the summary. So a lot of these have been studied in the context of summarization literature, and you might be interested in trying it out. It's an interesting problem. I haven't worked on it myself, but a lot of the times some encoder decoder architectures with interesting bells and whistles and task specific losses and data, etc., will get you a good starting point. I should also say that on the OpenAI front, if you have encountered a lot of noise since you have been working on it, please send it along to us. If not Keshav, the next student should really look at improving the quality of the OpenAI system. And if you are dealing with a lot of noise, we would like to help you out by improving it. So.
Sure. Thank you. That's wonderful. And I think I'm also told that we have reached the end of our allotted time. So with that, I would like to thank you. Thank you so much for even virtually coming and being part of celebrating FC Kohli's birthday and our FC Kohli Day at IIT Hyderabad. And I would like to now hand over to Nimi to take it forward. Thank you so much, Mausam.
Thank you very much, Vasu. It's an honor to be here. Very happy to present my work. And congratulations on the Kohli Day.
Yeah, so this is a very befitting end to the Kohli Day. Yours was the closing keynote. And thank you so much, Professor Mausam, for agreeing so readily when I asked you to deliver a keynote. Now I would ask Professor Madhav to do the closing honors for the day.
Thanks a lot, Professor Mausam. It's an amazing piece of work. I don't work in this area, so I can escape by saying, well, I because I don't work, I don't have questions to ask. But yeah, so the FC Kohli Day, as PJN introduced in the morning, is in the honor of Dr. Fakir Chand Kohli, the founder of TCS and the father of Indian IT industry, whose ideals we are trying to imbibe. And today we had a long program starting with a panel discussion and then followed by presentations of Kohli KCIS students' research work, and then followed by some faculty alumni interaction, and then two keynotes by Professor Rajiv Rastogi and Mausam. It's been a great day and a great evening we have had. Thanks to all of you. We hope to continue to be in touch with you, connected into the future. Thanks a lot.